Hello students. Today this is the lecture 3 of the chapter 1 of the class 9 physics, that is motion, and today we will discuss about the physical quantity in details. That will be a very short lecture, but that will be a very important lecture for the physics that we will study further in class 9 or class 10 or class 11 and 12 and further. So basically, before we have to study the concept about the different concept of the physics, that is motion or force or sound, energy, work, or all other concepts. We have to understand that what is physical quantity and how we categorize those physical quantity, and what is the significance of those physical quantities. We have to study differently, and what are the further usage of those physical quantity in our physics. So basically we start with the physical quantity. So what is physical quantity? In physics, the physical quantity are those quantity which can be measured, or which are capable of being measured, right? So we can define that the physical quantity are those quantity which can be measured. Okay, so here I am writing the definitions. That physical quantity, those physical quantity, those quantity which has capable of being measured. So those quantities which are capable of being measured, that means those quantity which can be measured is known as physical quantity. Okay, a physical quantity will always represent with a number followed with their units. Okay, a number, a simple number is meaningless in physics. So we have to consider, or we have to remember that whenever we use the physical quantity, or whenever we approach the numerical problems in physics in further concepts, so basically we have to write the units of that physical quantity in our answers, or anywhere that we use those physical quantity in the numerical problems or in theoretical explanations. We have to write the SI units or the units of those physical quantity. Either we are writing the SI unit or CGS unit or FPS unit or MKS unit, that doesn't matter, but we have to write the units. Okay, and according to that unit that we are using on that numerical approach, or that we are using on theoretical explanations, we will further explain those concepts truly. So basically the physical quantity are those quantity which can be measured, and a physical quantity will always represent with a number followed by their units. Okay, so we can write that it can represent as number followed by their units. So this is physical quantity. Okay, so in physics, if we write a simple number in relation with some physical quantity, then that is meaningless. Then there is no explanations about that number. If we write simply 5, then we cannot explain about that 5. That 5 will maybe for force, that 5 will maybe for distance, that 5 will maybe for displacement, that 5 will maybe for velocity, that 5 will maybe for work, or that 5 will maybe for sound. So that doesn't explain that 5, what that 5 will signify, or that 5 will explains what about those physical quantities. Okay, so if we write 5 meter, that means we are telling about that we are these 5 meters tells, if we write the 5 meters, so 5 meters tells about the length That length may be in terms of distance, or that length may be in terms of displacement. If we write 5 kg, so that 5 kg will explain about that we are explaining the mass of some body. If we write the 5 newtons, it means we are explaining the 5 newtons of force that will be applying in any directions or in any systems of or any body. Similarly, if we write 5 decibel, that means we are talking about the loudness of sound. So if we write simple 5, it is meaningless. But when we write the 5 with the following followed by some units, then it explains some specific physical quantity, right? So that's why in physics the physical quantity is very necessary, and in physics we are surrounded by the physical quantities, and the physical quantity are those quantities which are capable of being measured, and it will be represented by as a number followed by their units. And all those physical quantities are classified into two physical quantities, that is scalar physical quantities and vector physical quantities. So what does it mean, the scalar and vector physical quantities? So one by one we will discuss the scalar physical quantity. So as we know that the physical quantity have numbers followed by their units. So the scalar quantity has only magnitude. So a scalar physical quantity are those physical quantity which can be measured only as a magnitude. Okay. So here we write distance. So here we write distance, that is 5 meter. So here we write the 5 meters. So the number 5 is only represent the magnitudes, and the meter represent the units that will be represented, that will explain about some length, that in terms of distance. Okay, so distance 5 meter. Here the another unit is charge. Charge is a scalar quantity, that is if we write 5 coulomb, so 5 coulomb charge. So 5 is a magnitude that will be represented that will be represented for charge, and the coulomb, that is the SI unit of charge. So this whole concept, these whole things will explain that the 5 coulomb of charge that will be developed on any systems or on any body, or the 5 coulomb of charge will transfer, or the 5 coulomb of charge that will move. There are some certain possibility or any possibilities that will happen, but if there will be only magnitude, then it will be considered as a scalar quantity. Okay, so here speed is also a scalar quantity, like 5 meter per second. So meter per second is a SI unit of speed. The 5 is magnitude. So the magnitude followed by units. If there will be only the magnitude followed by their units, then those physical quantity are known as a scalar quantity. Here are some examples, like distance, charge, speed. Understand? Right? The electric potential, right? Electric potential is also a scalar quantity. Electric potential, like 5 volt. Now, so electric potential is also a scalar quantity because it has only the magnitudes. Okay, so we can write or we can say that a scalar physical quantity are those physical quantity which has only magnitudes. Okay, now what is vector quantity? So what will be the different concept about the vector quantity? So the vector quantity are those physical quantity which have magnitude as well as directions. Okay, so here one thing that will be necessary, that is directions. We will talk about the directions. So vector quantity, both magnitude as well as direction. Suppose, so in case of vector physical quantity, we will discuss both the magnitude as well as direction. So whenever we write the vector quantity, there must be a direction that will be associated with those magnitudes. Just we take on one example, that is displacement. displacement, that is we taken as 5 meter, okay, and consider that is east direction. So what is displacement? So the displacement we write at 5 meter east directions, okay. So here the magnitude that will be here the direction that will be associated with the magnitude, and in this way we can clear that anybody will displace 5 meter in each directions. They will not move anywhere, they will move in a particular directions, that will be each directions. If we write that 6 meter, if we write 6 meter in northeast direction, it means if anybody that will be displaced the 6 meter, that will be in a specific direction, and that is northeast directions, right? So that will be called the vector quantity. The vector quantity have magnitude as well as direction. The direction associated with the magnitude. There will be direction always associated with the magnitude. If we take another vector quantity like force, so we have 5 Newton in each directions or 6 Newton in north direction. So the direction will always associated with the magnitude of the force. Okay, so here the scalar quantity are those physical quantity which have only magnitude. The vector quantity with which are both magnitude as well as directions. Okay, displacement, force. There is another thing that is velocity. Okay, so velocity is also a vector quantity. Now we will discuss about some properties. So if we here we are going to discuss about the addition and subtraction properties of a scalar and scalar and vector quantity. So here we are going to discuss we are going to discuss about the addition and subtraction properties of the scalar and vector quantity. So here we are going to discuss about some properties of some addition and subtraction properties of scalar and vector quantity. So now we will start with the scalar quantity. So we will take some scalar quantity like mass. Okay, so suppose that is a block of mass 1 and it is a block of mass 2. Okay, so this block of mass is 1 kg and this second block have mass 5 kg. Okay, now we join these two masses. Okay, so we put a smaller mass on the larger mass. Okay, so this is 1 kg and this is 5 kg. Okay, so what will be the total mass? That will be 6 kg. Okay, so here we try to understand that addition and subtraction of a scalar quantity is a simple mathematical operations. What we done in the mathematical operations for subtraction addition, that will be simple. So because why it is simple? Because it has no direction associated with the scalar quantity. Okay, so a scalar quantity has no direction, so there is no difference of directions with the numerical magnitude that will be associated with some physical quantity. So that's why if we take two masses and they will be combined together, so there will be mass combined together simply. So if one is 5 kg and one is 1 kg, if both are combined together, so the total mass will be 6 kg. Okay, if we take the distance, so suppose the ram will travel from point A to point B for 5 meters and from point B to point C in 6 meters. So we simply added, because the distance have only the numerical value and they have same unit as well as, so the 5 meter plus 6 meter, the total 11 meter. It means the ram will total travel 11 meters. Okay, so that's why that is called a scalar quantity, because it has only magnitude, and the addition and subtractions is as simple as in mathematics. So because a scalar quantity has only magnitude, so the magnitude with the similar units will be added or subtracted simple. Okay, the main concept about the vector quantity is that if we try to add two vector quantity with the same units and we if those vector quantity have similar directions, then we can simply add. Okay, so suppose there is a displacement of 5 meter in north directions. Okay, and then again there is a 6 meter. There is a there sorry there is a displacement of 5 meter in north direction, and there is a displacement of 6 meter in north directions. Okay, so what happens that, consider this is RAM. Okay, and the RAM will displace from point A to point B. Okay, now point B to point C. Okay, now if consider the directions, so consider this is east, this is east, so north, south, east, west. So the first, from point A to B, consider that RAM will displace the 5 meter in north direction. Again from point B to C, this RAM will displace the 6 meter, and finally they will reach to point C. So what will be the total displacement from A to C? So the total displacement from point A to C is that 5 meter in each directions, and plus 6 meter in each directions. So the total displacement is 11 meter in each direction. So what we understand in vector quantity, that the vector quantity can be simply add or subtract together with the similar directions. So here we see that RAM displays 5 meter in north direction, as well as it displays 6 meter in north directions, right? So the total displacement is 11 meter in, the RAM RAM displays 5 meter in each direction and 6 meter in each direction, so the total displacement is 11 meter in each direction. So that is called vector quantity, because these vector quantity have magnitude as well as directions. But consider that if the RAM will again comes from point B, suppose there is another example. So suppose this is point A and this is point B. Suppose this man displays firstly from point A to B in each directions. Okay, and then again that will be come toward the A, that is in west directions. Okay, that is in west direction. So what happens, the RAM, this person displays, suppose this is 1 meter, so this person displays from A to B 1 meter in each direction, so 1 meter in each directions. Okay, and now again it displays from B to A in west direction, so 1 meter in west direction. So now what will be the total displacement for this person? So it will be 0. It will be 0. So we cannot add simply, because 1 meter first we erase these things. We start from here. So what we are starting, that a person that will displace from point A to point B, and then it again from point B to A. So here 1 meter in east direction, and here 1 meter in west directions. So the total displacement of the of this person will be 0. How it happens? So first from point A to B, it displays 1 meter in each directions. Now point B to A, it will be 1 meter in west directions. Okay, so the west direction is opposite to the east direction. So in this way we can write that 1 meter each directions, and this can be written as minus 1 meter, and what is each directions. So this negative signs signifies that this 1 meter will travel by this persons in the opposite direction of east. Okay, so now we will add together. So 1 meter each direction plus minus 1 meter each directions. and what will be the total displacement? That is 0 meter. So that's why the vector quantity is a special and that's why the vector quantity is especially treated. So if we take the same directions, that will be that time we can simply add it, okay, or subtract it. But when the direction will be opposite or when the direction will be changed, we cannot simply add it or subtract it, okay. So in this vector quantity, but in case of a scalar quantity, the both any type or any number with the same physical units or same units, that can be simply added or subtracted, okay. So I hope you understand that what is physical quantity and what is physical quantity, what is a scalar and vector quantity, what is the properties of a scalar and vector quantity, and what is the significance, right. Vector quantity will be represented. So the vector quantity will be represented, suppose this is a unit, so vector quantity will be represented with the arrow sign up, upward arrow sign. So basically this will be the representation of vector quantity. So this is the symbol of consider if we can suppose there is a distance, okay. Distance have distance in physics, distance will be symbolized with s, as well as displacement also symbolized with s. But how will differ that this s is distance or this s is displacement by this sign. So if this symbol have this sign, that means this s represent the displacement, because this arrow sign indicates that this symbol has some directions. So the displacement is a vector quantity because it has magnitude as well as direction, so it can be represented as s, okay. So distance s, okay, so it is simply represented as s. It has no arrow signs. So when it has no arrow sign, that means it signifies the distance and it has no any directions, okay. So the distance is a scalar quantity and the displacement is vector quantity. So vector quantity will represent these symbols and scalar quantity will simply represent by simple symbols, okay. They have no arrow signs above their symbols. I hope you understand that what is scalar and what is vector quantity and what is the properties of addition and subtractions of the scalar and vector quantity, and definitely it has more significant in physics in the higher classes. So we will study lots of about the vector quantity in higher classes. Right now we are ending these lectures about the physical quantity. Thank you. In next lectures we will start finally the distance and displacement. We will study about the different concept of distance and displacement. We will study about the different relation between the distance and displacement. We will study about the different various differences between the distance and displacement, okay. Thank you.